I hope by now, in the first part, as we have done about binomial theorem, in this we will be going more deep into that, and we will be studying important points of expansion basically, and based on that we will be also doing question in this part, so the basic idea of binomial will become bit clear. And the question where we started, something raised to power something divided by something, what will be the remainder or the last digit? I'll answer in this video. Let's begin with the part. Continuing from where we left in the last part, let's look at the results or important points which I mentioned in the last part also. So again, as said, there are n plus 1 terms if the index is n. Then sum of the powers in each term is always equal to n. Again, a very important point, okay? That is one again very important point. The general term, again, this point will be covered in more detail in the coming parts. That, okay, I said something like that we will start with NC0, then x raised to power 100. If you remember, if I wrote x plus basically y raised to power 100 will be equal to NC0, something like this. So a generalized term, and I noted a point in the previous part also, some kind of summation notation was written if you put your attention on that. So this is basically general term. Now why r plus 1? Because we are starting with NC0, that is the first term. So we want to make that 0 basically in terms of number of terms. So that is plus 1 of this index. And what was the criteria of the power? Index minus this one for the first term, and for the second term it was just the subscript. Here if you see, it will be 100. Now 100 minus 1 will be x raised to power 99, and 1 will be y raised to power 1. So please carefully note general term, although we are going to discuss it in more detail in the coming parts. Okay. After this, again, this is also important result. The pth term from the end will be, again, I go by writing an expansion maybe. Suppose if you are looking for x plus y raised to power 10, okay, and if I say third term from end, okay, now what does it says? N minus p plus 2 means 10 minus this will be, p will be 3, that is third term from end, plus 2, that will be equal to ninth term from the beginning. Now let us see how many terms are there. 11 obviously. Now we are saying third term from the end, so third term will be 11th, 10th and 9th, which will be 9th from the beginning. So this is again an important thing, that pth term from end is obviously n minus p will be going. Now this 2 comes because there is one extra term, plus we are counting the last term as the last term, okay. So obviously this we have to shift. If we are saying second term from the end, okay, obviously there are one more term and the last term itself is included, okay. So we have to add, this 2 comes out because of that factor, okay. So after this, coefficient of x raised to power r, again to be carefully noted this point also. X raised to power r in this form, again as I said, okay, you can go either way. We'll see. Again, this is more better if I put it like this, x raised to power a raised to power n, okay. We will see that ultimately these both will be same for this also, for this also, yeah. But again, if I look at this, so I said general term will be NCR, where the coefficient of first term will be x raised to power n minus r, and the second one will be a raised to power r. So since we are looking for x raised to power r, we put it on the second number, and that is why it is being appeared like this, okay. In general, you will be finding that this NCR and this both will be same. Even if I go for this one r, then it will also be same, okay. We'll see this property in the coming when we will be doing binomial properties, coefficient, basically properties of binomial coefficients, okay. Yes, this one I was talking just about that. Now if I'm writing this, Okay, there can be two cases. Either suppose I am writing 100C3 is equal to, either this y will be equal to 3 only, or this y will be equal to 100 minus 3, that is 97. Now what is the purpose of this? Again, as we look, x square plus y square, or 2xy basically, plus y square. Looking from this expansion again, I said there is a pattern that the beginning and the last one, they are being same. Okay, so the pattern has to be followed, and again, as I said, that from beginning and end it will be same. So this was NC0, this was NC2, basically 2C0, 2C. So as you can see, either the sum has to be same or the coefficients. If it's same, then obviously there is no confusion about that. Okay, so you need to keep this property also in mind while doing the questions. Okay, so let's solve some questions based on whatever we have discussed till now. Okay, let's look at the first question. Find the last digit, last two digits and last three digits of this one. Now this is the first very important application of binomial theorem, straight away taking to your competitive exams. Okay, yeah. So in this type of, again you will say this is a single term thing, how we can make it binomial. Okay, now for finding the last two digit, okay, last digit or last three digit, we need to express it near some base. Now base means I need a 0 basically, maybe in the end, 2 zeros in the end. Okay, so one way is writing this like this, but again I don't need a 3 here. I'll tell you the reason. That now if I go for this expansion, I'll start with, suppose 2 raised to power 20 raised to power 256. I'll end up with 3 raised to power 256. Again, this will create a problem. I don't want 3 here, unwanted 3 here. So my purpose will be to make near to the base such that this becomes 1. Now what we start with? We start with squaring the things and taking 2. If I take 2 here, now 17 square is clearly 289, sorry, raised to power 128. And this one clearly solves my purpose. Yes, because I can now write it as 290 minus 1 raised to power 128. Now in this one, as you can see, I'll start with 290 raised to power 128 and I will end up in 1 raised to power 128. So clearly 1 doesn't have any effect because it will be 1. Okay, so I can have basically last digit, last two digits, again I will tell how we will get, and last 2 digits again. So now the first purpose is to make near base and manipulating this and make it as a combination of 2 numbers, and out of those it's preferably one should be one of them. Okay, because that 1 raised to power anything is 1 only, so we will only need to worry about the 1 term. Okay, so now let's expand it using whatever we have learned. Okay, and see what do we get. Okay, this is again 128. So I'll start with 128 C1 C0, 290 raised to power 128. 128 C1, I'll write 2 terms, then I'll write from end. I'll tell you the reason also. Now this will go up to 128. Let us write last 3 terms because again we are concerned with last 3 digits, and as you can see the number of zeros, so it will have 128 zeros, obviously not of use. This is having 127 zeros, again not of use. Okay, so last 3 terms will again be appearing like 126. So 290, it will be square and into 1 again. Now again here the minus 1 is there. Okay, we have learned that a plus x, like that, expansion like that. So if it's minus, no need to worry. Why? We can write this as a plus minus x, doesn't matter. Okay, so we can just write minus 1 here raised to power 126, then plus 128 C 127 290 into odd power plus last will be even power plus, and it will be 128c 128 290 raised to power 0, and 1 will be getting nullified. Okay, so this will be 1, this is also 1. So obviously now let us see that this one is having 1 0, this one will be having 2 zeros. So last digit will only be from this. Why? Because it will gonna end in 0. It will gonna be something like 0 0 something, something here. It will be 0 here and something here. This will be plus 1. So if I add this one, last digit is solved. 1. Okay. Now before this, you will have basically 290 raised to power 3. In those, 3 zeros will be there. So basically whatever will be there won't be affecting our. So this is our only required result, that we need to explore that how we are gonna get this thing. Okay. And this I can write again anything, m into 1000 doesn't affect. Now this one again I need to solve the coefficient 128 in factorial, 2 factorial, that is 128 minus 126, and 126 factorial, and this will be 290 square. Okay, and plus, because it will is a even power. Next one will be minus. Why? Because there is an odd power. So it will be 128 factorial, 1 factorial, 127 factorial, and it will be 290, and that there will be plus 1. Okay, now just by solving these things, okay, obviously now this last term is being detected. Okay, second last term we can just get by solving these two. Okay, so once you solve this, you will get now this one you can, how it will solve 126 factorial, you can write this as 128 into 127. Okay, and upon 126 factorial, that will be getting cancelled. Okay, so this way you can solve this one. Similarly, this one will only be 128. 127 factorial will get cancelled, so you will get a number 681 and something here. Okay, so obviously your second last digit will be 81, and this you can check basically, not wasting time on calculations. The concept here was to make it in this form. So this will be very helpful, even not for even IIT entrance, even if you go for post graduation when you will be appearing for CAT also. So this will be helpful in that also, plus aptitude paper wherever you will be going for any entrance. These type of questions will again be very useful. That find the last digit, remainder questions like that. What happens if the number is divided by some divisor will be given? So in that case also we use binomial theorem. Why? Because first powers we will try to express as a multiple of the divisor, and then the remaining last 1 or 2 term will play as a role of that thing, forming the remainder part. Okay, so this is again very good. Do it again on yourself, and again the basic aim is to make this in this form, and zeros help us basically. Why? Because as you can see that we don't need to play with this terms and before. Why? Because they are having more zeros, so we don't need them basically. Okay, let's look at one more question. If the coefficients of second, third and fourth term in the expansions are in AP, okay, of this, then we have to show that n is equal to 7. Okay, now as you remember, the expansion of this was, again we will go start with nc0, 1 raised to power anything is 1, plus nc1, and here the x will be raised to power 1, plus nc2, x raised to power 2, it will go up to nc7, or we don't know basically. Okay, ncn, x raised to power n. Now we need to show that coefficients, this is given, second will be, now again note here the common mistake, second term if you don't remember that TR plus general formula notation, this will go wrong. Second term you need to substitute R as 1, keep that in mind. Okay, this is the second term, not this one. Otherwise many students they think, okay, second term NC2, this is actually the third term. Okay, so please make sure, don't make confusion in that. second, third and fourth. Okay, so basically coefficients we are gonna equate. So second is NC1, third one is NC2, and the fourth one is NC3. Now these are in AP, okay? So obviously twice of middle one will be equal to NC1 plus NC3. Now just solve these things, okay? Now this will be giving me n factorial over n minus 2 factorial into 2 factorial, n factorial over 1 factorial, n minus 1 factorial, plus n factorial over n minus 3 factorial, 3 factorial, okay? Now solving it here, we get basically this 2 factorial will get cancelled with this. This will be n into n minus 1, rest will be cancelled, so we don't want anything in the numerator, okay? So this will be equal to, now again this one is very easy, only n will be left. Now this one is a bit tricky, n into n minus 1 into n minus 2. Then n minus 3 factorial will get cancelled with n minus 3. And don't forget this 3 factorial. This happens, okay? So now obviously n is not equal to 0, obviously, because since we are saying second, third term, so our coefficient cannot be 0, so we can cancel out n easily. Now this becomes an easy quadratic. So 6 I can take as a basically LCM. So 6 plus, now this will be n square minus 3n plus 2. So 6n, what I'll do, I'll simplify it here. N square 6n, I'll take here minus 9n. This is plus 8 and this will be 14. So this will clearly be forming n square minus 2n minus 7n plus 14. That will be equal to 0. We can do it using middle term splitting or maybe directly quadratic formula, those who are familiar with that. Okay, so it will be n into n minus 2 minus 7 n minus 2, that will be equal to 0. From here you can easily get n as 7 or n as 2. Now here n cannot be 2. Why? Because you're saying that we are having second, third and fourth term. For n equal to 2, there will be only 3 terms, first, second and third. Okay, so that's the clue for this. I think that if those who don't remember n plus 1, so if in a question in IIT, how the question will appear, it won't show that n is equal to n. It will say find the value of n. In options it will be given 2, 7, 2, 7, none of these, like this. So perfect, it becomes a question for JEE mains. 2 or 7 it will be written, and again those who do not remember that the number of terms are one more than the index, they will obviously mark it wrong. So please keep that in mind. Do revise the properties again and try to solve some more questions based on the expansion only. Okay, we will be studying more complex properties, more detail about the coefficient in the coming parts. So here we are at the end of the second part, and I hope that you must have noted the important points in the expansion, and the points which we noted in the previous part were elaborated, and we have also performed question based on that. So I hope that by now you will get a clear idea of what lies ahead. Stay tuned for more videos.